Hello learners, welcome back. In this video, we are going to solve another question from the properties of fluid. So here goes the question. The question says that through a very narrow gap of height h, a thin plate of large extent is pulled at a velocity v. On one side of the plate, the oil of viscosity mu1 and on the other side, the oil of viscosity mu2. Calculate the position of the plate so that the shear force on the two sides of the plate is equal and the pull required to drag the plate is minimum. So there are two questions. This question has been asked previously in ESE 2008 for 10 marks. Let me explain you the question. The question says that there is a plate, this plate, which is moving with a constant velocity. It is being pulled with a constant velocity v. And the distance between these are fixed plates, and the distance between these plates is h. Okay, this distance is small h. It's given in the question. Now there is oil filled here as well as here. The viscosity of the oil in the upper portion is mu1 and in the lower portion is mu2. Now the question says you have to find out the position of this plate such that the shear force on two sides of the plate are equal. So whatever shear force is acting on this side of the plate must be equals to the shear force acting on the other side of the plate. This is the part 1 of the question. Now the part 2 of the question is that we have to find out the position of the plate so that the pull required to drag the plate, this pull, that is the this force which is required to pull the plate with a constant velocity is minimum. So I hope the question is clear to you. Now let's start solving this question. Let's start with part 1 of the question. So here the viscosity is mu1 and the viscosity is mu2. The plate is moving with a velocity v, constant velocity v, and this is the height of the plate is h. Okay, now let's take that this height is x. Now what will be this height? This height will be h minus x, isn't it? Because the total height between the two fixed plates is h, and these two plates are fixed, and this is the moving plate. Okay, now according to question, the shear force on the two sides of the plate must be equal, right? So let this be part 1 and let this be part 2. So let me write it as shear force on 1, that is the top of the plate, must be equals to shear force on 2, that is the bottom of the plate, right? Now from the Newton's law of viscosity, we know that shear stress tau is equals to mu du by dy, right? This is from the Newton's law of viscosity, and we have to find out the force. This is stress. If we multiply this by area, suppose on both sides, we are going to get force, because stress into area will give us the force, right? So let the area of the plate be A, and what we are going to do, we are going to equate the forces on both sides. Okay, so let's do that. So F1 must be equals to F2, that is the force on the first side, on the top side of the plate must be equals to force on the bottom side of the plate. So how is force acting? If the plate is moving in the right hand direction, the force will act something like this. Okay, so this is the force, direction of force. It will act something like this. This is the force of friction. So for the top layer, what it will be? What is the viscosity? Viscosity is how much? Mu1, right? Mu1. What is du by dy? What is the velocity of the plate at the bottom? What is change in velocity? Actually, the velocity here is 0, right? And velocity here of the fluid is capital V. That is the same velocity as the plate, right? So what is du? Change in velocity. Change in velocity will be v minus 0. That will be v only. What is dy? What is this change? This change is being carried in the distance of x. So we will be writing x over here. Okay, so mu is done, du by dy is done. What is the area? Area of the plate is A. Okay, same thing we are going to do in the right hand side. What is the force on the plate on the right hand side? It is mu du by dy into A, right? What is mu over here? What is the viscosity of the oil? It is mu2. What is the change in velocity? Change in velocity is again v minus 0, because the velocity of the fluid over here is v, that is same as the velocity of the plate, and the velocity of the fluid over here is 0. Okay, so it is v minus 0. Now what is the distance by which this velocity change is taking place? It is h minus x, this one, h minus x. Okay, so let me write it down. It is h minus x. And what is the area of the plate? Area of the plate is A. Let's solve this and we are going to get the answer. Basically, we have to find the value of x. So solving this, we get A and A will get cancelled out. That is the same thing. So A and A will get cancelled out. Next step is mu1 v by x is equals to mu2 v by h minus x, right? Or we can write it as, let me solve it here, h minus x by x is equals to mu2 v by mu1 v. This v and v will also get cancelled out. I'm sorry that I didn't do that in the previous step. So this v and v will also get cancelled out. So now h by x minus 1 will give you mu2 by mu1. Okay, and you have to find out the value of x. So what will be h by x? H by x will be mu2 by mu1 plus 1. This 1 I am taking to the right hand side. Mu2 by mu1 plus 1. Okay, so let me write it down. H by x is equals to, this is mu2 by mu1 plus 1. Mu2 by mu1 plus 1, which will give you h by x is equals to mu2 plus mu1 by mu1. And then okay, then if we just reverse it, x by h is equals to mu1 by mu2 plus mu1, or you can write x is equals to mu1 into h by mu1 plus mu2. So we just found out the distance. Okay, so this is the required distance. If the plate is at a distance x, which is mu1 into h by mu1 plus mu2, so this distance x is equals to mu1 into h by mu1 plus mu2. If this is the distance, then what will happen, that the force on the top side of the plate is same as the force on the bottom side of the plate. So this was the part 1 of the question. Okay, let's move ahead with the part 2 of the question. Let's see what is the part 2 of the question. The part 2 of the question says that what is the position of the plate so that the pull required to drag the plate is minimum. So whatever the force is required to drag the plate is minimum. Okay, now let's see. The plate is moving with a constant velocity v. It is given in the question. The plate is moving with a constant velocity v. Okay, that means whatever the force is being applied over here, F, it is getting countered by the force of viscosity, or you can say by the force of friction which is acting over here. Now let this be force 1 and let this be force 2, because there are two liquids with two different viscosities, mu1 and mu2. So these two liquids are applying different forces to the plate. So the total force F must be equals to F1 plus F2. If these two forces are equal, then only what is going to happen, these two forces are equal and opposite in direction, so the net force is 0 and the plate is moving with a constant velocity v, and there is no net acceleration. Now we have to find out the position of the plate so that this force required to drag the plate is minimum. Okay, so how we will do that? Let's again take this distance as, now let's take the distance this as y, and let's take this distance as h minus y. Okay, because the total distance was here, I should write it here, because the total distance from here to here was h. Okay, so what is the force F1? Let me write it down. What is the force F1? Force F1 is nothing but, from the Newton's law of viscosity, we can write stress into area, shear stress into area. Now what is that? Shear stress is mu du by dy, right, into area. So we are going to use this equation only. So for the first part, what is mu? Mu is mu1. What is du? That is the change in the velocity of the fluid from one end of the plate to the another end. It is v minus 0, right? And what is dy? First, for the first part, it is y, right? And area is a. Now let me just rub this down. For the second part, what is the force? The force is mu2, velocity is v minus 0 by h minus y into area. So this is the total force. Now for the total force to be minimum, we have to differentiate it with respect to y. Okay, for F to be minimum, df by dy must be equals to 0, right? If we do this, we are going to find out the value of y, or the position of the plate. So let's do that. So force is how much? Let me just solve it a bit. So v by y into area plus mu2 v by h minus y into area, right? Now df by dy will be, so these are the constants, mu1, v and area are the constants, so we'll take it out. Mu1, v and area are constants. It will be dy by y plus again mu2, v and area are constants. It will be dy by h minus y, and that should be equals to 0. So this implies this v and a will take out common. So it will be mu1 into dy by y plus mu2 dy by h minus y, and that will be equals to 0. Now if you differentiate it, you will get mu1 minus y square and then plus mu2 h minus y whole square, and this will come out to be 0. So let's solve this one. We'll take 1 to the other side of the equation. So let me write it here 0 and then rub this a bit so that I can solve it here only. Or you can write it as mu2 h minus y whole square is equals to mu1 y square. Now it will be, you can write it as mu2 by mu1 is equals to h minus y by y, and it will be whole square. Or you can write it as under root mu2 by mu1, which will be equal to h by y minus 1. Or solving this further, we get under root mu 2 by under root mu 1 plus 1 is equals to h by y. Or you can write it under root mu 2 plus under root mu 1 by under root mu 1 is equals to h by y, right? Or y is equals to h into under root mu 1 by under root mu 1 plus under root mu 2. So this is the value of y, or the position of the plate, so that the force required to drag the plate is minimum. This is the required answer. Under root mu 1 into h by under root mu 1 plus under root mu 2, and this distance is from the top of the plate. That means this is the value of y. Okay, this is the value of y, required distance of the plate from the top. So that's all for today's class. Hope you liked the session. Bye bye and have a nice day.